Alright, so here we have our chrono. On the top two we have infrared diodes, and then on the bottom here we have two infrared transistors. Basically they're saturated because the light is shining through and saturating the infrared transistors, making it a 0.2 voltage at the signal wire. The signal wires are these two here. Basically when something passes through, it takes all the base current out of the transistor and makes the transistor unsaturated, making it about 5 volts. Here we have RC1 and RC2 hooked up here, and these are capture interrupts looking for rising edges, so looking for that 5 volt spike. And when that happens, it'll take the time of the first entry, time of the second entry, and then subtract the two to find the event time. And the chrono, these are spaced 10 centimeters apart, so from that you have distance divided by time, so you can find your velocity.
So we're going to do a demonstration on just how it does a quick reading on it. Got to make sure it goes through the middle. So it shows here on our board the shot number that you're on. Right now it's displaying meters per second, feet per second, and miles per hour. And then we also have that same data being sent to the serial port in feet per second, meters per second, and miles per hour.
Alright, so the whole point of this was to see the velocity of a paintball gun. We're going to find a 90% confidence interval of the average velocity of this paintball gun. So just going to shoot at least 50 rounds through it and then do our calculations.
Alright, so we borrowed an actual chronograph from a friend of mine, and we're going to use this and compare it to our results from the one that we made. $293,
293,
292.65.
Alright, so for our project, we utilized 3 different timers to get it done. So the first timer that we used is timer 1, and that is just always keeping track of time. It's always incrementing time, but since it only goes up to 65,536, we had to make another variable to keep track of a longer time. So we made a variable, long, called time, which is 32 bits, and every time that timer 1 overflows, it adds on to time. So we never lose any of our time, I guess. Second interrupt we used was a capture interrupt, and when the LED is blocked, the capture interrupt will keep track of whatever our long time is, and it adds that on to what timer 1 is at, and it stores that in a variable called start time. After that, when the our third interrupt is our second capture interrupt. And that takes when the second LED is blocked, and it takes our long time interval and adds that on to whatever timer 1 is and stores that as end time. And also in that capture interrupt, we have a variable called event time, which is our end time minus our start time.
I don't know if you should wait this over.
While
While you're talking.
Oh. Gosh, what do you want me to talk about?
No, nothing. No.
While you're doing that.
Also a part of our third interrupt, our capture interrupt, at the end of it we have a variable called out, which we set to 1, which is used later in the code. Alright, so in our main routine, we start off by initializing our pick and initializing all of our ports. After that, we go into a while loop, where the first part of the while loop is some if statements. We check whether RB0, RB1, or RB2 is pressed, because if one of them is pressed, we need to change a display value so our LCD displays something different. Also a part of each of those if statements is a variable called change, which essentially acts as a flag. We set change to 1, so the program knows later that it needs to do a certain function and change our display based on what we set display to be. So if change is 1, so if RB0, 1, or 2 has been pressed, we go into an if statement, and it checks what display value has been set as, either 0, 1, or 2. If it displays 0, for instance, the LCD will display meters per second. If it displays 1, it'll display feet per second, or displays 2, it'll be miles per hour. At the end of the if loop, we then set change to 0, so the flag is essentially off. And every time this routine runs, it doesn't need to go through that if loop. Good? All right. So as I said before, during our second capture interrupt, we set a variable called out to 1, and this is the if loop that is utilized. So if out is equal to 1, we increment a variable called shots, so we know that we've taken another shot, and then using the event time that we've recorded and knowing that the two LEDs are 10 centimeters apart, we can calculate meters per second. Using conversion factors, we can then calculate feet per second and also miles per hour. We output that into hyperterminal once per shot, and then at the end of the loop we set out to 0, so that the next time this goes through, unless another shot has been taken, we don't enter this if loop. So before, when we were changing our LCD, we would just change the output label to meters per second, feet per second, or miles per hour. In this portion of our code, the end of our code, we output what those numbers actually are, the actual result that we got from our last shot. So if display is equal to 1, we output what that shot was in meters per second, right here. If display is equal to 0, excuse me. If display is equal to 1, we output feet per second, the actual value of feet per second, next to the label, feet per second. And if display is equal to 2, we output what the speed was in miles per hour. The reason we don't have our LCD display the actual value function within our if output loop is because we want to be able to check our meters per second, feet per second, and miles per hour values without having to shoot another shot. So this way we can just enter RB0, 1, or 2 and then see whether it is meters per second, feet per second, or miles per hour without having to shoot another paintball. So this LCD output is different from the computer, where the computer can take all 4 values, shots fired, meters per second, feet per second, and miles per hour at once, whereas our LCD only has 2 lines, so we can't display all 4 pieces of information. So we have different buttons to display what we want to see.